Hi, my name is Valerie Carranza. I'm a PhD candidate at the University of California, Riverside. The focus of my research presentation is on isotopic signatures of methane emissions from dairy farms in California's San Joaquin Valley. Methane is not only a powerful greenhouse gas, but it is also relatively short-lived climate pollutant, making it an ideal greenhouse gas to target for near-term climate action. California is at the forefront of reducing methane emissions by setting ambitious greenhouse gas reduction legislation. However, there are some important research gaps that need to be addressed. At the global scale, methane has been steadily rising. At the same time, the stable carbon isotope ratio values of methane have become more negative, and it remains unclear what is driving this rise in methane globally. Therefore, more measurements of carbon isotopes of methane are needed to help constrain the relative contribution of methane sources. In California, there are large inconsistencies between atmospheric observations and greenhouse gas inventories, so we need a better baseline to track mitigation progress. The objective of this research project is to, 1, measure the isotopic signatures of methane emitted from anaerobic manure lagoons and enteric fermentation source areas across seasons, and 2, to use these isotopic signatures of methane to identify the dominant source of methane hotspots downwind of dairies. To do this, we have our dairy site in Central California shown here. We also measured downwind of dairy farms in this region here using the mobile laboratory. The mobile laboratory measured methane and isotopic signatures of methane with gas analyzers across different seasons. What we found was that across all seasons, the stable carbon isotopic signatures of methane emitted from manure lagoons is more enriched than methane from enteric fermentation across seasons, on average by 14 per mil, as shown by this figure here. Meaning that stable carbon isotope measurements of methane can be a valuable source of apportionment technique to distinguish between enteric and manure methane. We also found that the isotopic signature of methane varied between different cattle production groups based on diet composition, as shown by these two figures here. For example, the breadth of milk-room cows and hutch calves had more enriched isotopic signatures than other cattle production groups. And based on feed data, we found that the diet of milking cows and hutch calves had a higher percentage of C4-based feed compared to other groups. This in turn impacts the isotopic signature of methane observed. Lastly, we found that downwind plume sampling of stable carbon isotopic signatures of methane can be used to characterize enteric and manure methane. We observed that isotopic signatures for methane hotspots from downwind plume sampling of other dairies in the region were consistent with on-farm isotopic signatures, as shown here. For example, downwind plume sampling at this dairy resulted in more depleted isotopic signature value that's representative of enteric methane. And we found a similar pattern at other dairy farms that are shown here in this table and in this figure. This implies that measurements of carbon-13 and methane downwind of dairy farms may be a useful tool to monitor and quantify enteric to manure ratios with changes in mitigation. Thank you for your time.